In this session, we'll look at existing ground cross-sections. The objectives here is to generate existing ground cross-sections based on a horizontal alignment and the surface model beneath the alignment. And also to review the cross-sections using the cross-section Navigator. The existing ground cross-sections are created using Geopak 10 file or using a Geopak 10 file or the surface model, a proposed alignment, and pattern lines if this particular method is chosen. So let's go into a Microstation file and look at the creation of existing ground cross-sections. Now, to access this, we're going to go and open up our project manager first. We'll open our project. And we have existing ground cross-sections, and next to existing ground cross-sections we have draw patterns. Now, I've opened a file called xs.dgn, and that's where I'm going to draw my existing ground cross-sections. But first I'm going to go into a file and open a file called pat.dgn. And in this file I have drawn my alignment and station by alignment. And I'm going to go and select draw patterns. I get a run box, say OK, move this out of the way. And we have our job number, we have our alignment, and then we can place from beginning to end the offsets left and right. This is the beginning station, the ending station, and the offset left and right of 125 feet. Now, the distance should be determined, or should be the result of the distance of the proposed right-of-way. In other words, we should try to get outside, just outside the proposed right-of-way with our pattern lines. In this case, I'm going to use 125, which is going to give me a total pattern line length of 250 units. I can do this with increment, even, with every even station, do it one time. Control points horizontal, vertical, and the super elevation at every super elevation transition. But I'm going to do increment. I'm going to do this at every 50 feet. I can do this on a skew angle, but in this case I'm just going to do them perpendicular to the alignment. And then I'm going to go and double click into this area where it says level symbology and pick a level symbology for these pattern lines. Say OK, and I'm going to say draw pattern lines. Now, the reason that we use pattern lines is simply for their flexibility. In other words, what I can do with a pattern line is actually go in and utilize the Microstation modification tools. And let's open up that toolbar. And if I want to extend one of these lines or several of these lines to catch some information out here to the right of the alignment, I can extend these lines, and wherever those lines are extended to, that's how wide the cross section will be at that particular location. Now, one thing that some people do is that they will draw their tin hole, in other words, the actual limits of their tin file in this file also, to make sure that we're not exceeding that, because we can draw a pattern line out to that area or that line, or even past that line, but the only place that you're going to get any data is inside the tin line or the tin hole line. So the reason we use pattern lines is strictly for the flexibility that we have with the pattern lines. So we're going to leave those out. Close this. And I'm going to go back to my existing ground cross-section file. And now we're going to select existing ground cross-sections. Select the run box, say OK. Move this out of the way, and we get our existing ground cross-section box. Now, we have our job number, we have main line, we have our cross-section cells. Now we're doing this by DGN file. We can also do it by station. We don't have the control that we have with pattern lines by station. By station, we simply put in the beginning and ending station, the offset, and then the increment, and then the offset left and right. But in this case, we're going to do an existing only, but we're going to do by DGN file. Our DGN file is pat.dgn. We're going to go in and do a reset here, and we're going to open up our pat file, and we're going to do a match. Select the match button, select one of our pattern lines, accept it, and it puts that information in here for us. Now we can just go back to our cross-section file. My cross-sections, the cross-sections I'm going to draw here are going to be drawn at 2:1 scale. Draw them at 1:1, 5:1, whatever you typically draw your cross-sections as far as the horizontal vertical scale. The horizontal distance that they'll be placed apart, the distance that will be placed apart horizontally is 1,000 units, and then vertically is 500, and then you have the number of cross sections per column. These are all just the default numbers. They can be modified to whatever you want them to be. Now once we have this information in here, we're going to go into the surface area. We're going to go to 10 file, and our 10 file is ground.10. The method we're going to use is triangles, and we're going to do by level symbology. And I'm going to double click in this area, and I'm going to pick a color. I'll just pick green, and the line style and weight is fine. If I want to put an elevation at each center line, I can do that. I can double click in this area. I can do it, set my information here as far as my text height, text width, the type of font I want. If I want that rotated 90 degrees, if I want a horizontal offset of, let's say, 2 feet, say OK. If I want to do, if there are any voids in this particular alignment or adjacent to this alignment, I can plot those also in a different color. I can do this maybe white with a heavy line so that they'll stand out. Once this information is filled in also, then I'm going to add this to this collection box. Now all I have to do is hit the draw button, and it will draw my cross sections. If there's a particular place that I want the cross sections to be drawn, then I can select this and go out and just hit a data point for the beginning location. But in this case, I'm just going to hit draw. I'm going to close the box, save the settings, and do a fit. And here are my cross sections. Now it's hard to see, but you can see that we have a widened area here. And it's hard to picture which one of these cross sections is which. So we have what's called a navigator, cross-section navigator. And I'm going to close up my CAD tools. I'm going to go to Road. And right here I have my cross-section navigator. It's a little ship's wheel. I'm going to select the cross-section navigator. It brings up the first cross-section. And also it brings up a little menu bar, a little toolbar that I can use for navigating my cross-sections. If I want to go to a particular station, I can pull down this arrow, go to, for instance, 311 +00, and there's that cross section. I can go all the way to the beginning. I can go recenter the cross section. I can toggle through these one station at a time. Go all the way to the end. I also have tools for DP offset elevation. DP offset elevation, there's two options here. One of them is to send a data point. So if I know the elevation and the offset, I can send a data point to that location, or I can get cursor cross-section position. So if I select that and go anywhere on the cross-section, excuse me, you'll notice that this information is changing in this box. This cell has intelligence, so it knows the offset and elevation wherever my cursor is. So I can either send a data point, or I can get an offset and elevation of any location along the cross section. I can also do a DP delta distance slope, active angle tool. I have an active angle tool. I can draw a cross section. If I want to do the slope at run rides, I can draw one at 3:1 slope at a delta distance, we'll say, of 25. Hit a data point and it draws a line at 3:1 slope at 25 units long. Okay. And then I can go back to my first cross section, and that's how I can view my cross sections. Now you'll notice as we go through here, you can see the changes in the roadway or the existing ground. And as we move along, we will come to that area where we have a wider cross section, where we have our wider pattern line. Now, this concludes our lesson on creating existing ground cross sections with a pattern line.